into this GPL example. So go to Ishmael. I'm going to close the detection window. Let's load the factory settings. Back to where we started. Detection workshop. Ishmael factory settings. Here we go. And so this detector is called the Generalized Power Law, GPL detector. It's a technique that Tyler has come up with and implemented in Matlab. And it was one of the first two cases of types of detectors that we did using the Matlab interface. The very first one was just a simple energy sum. Energy sum already exists in Matlab, but we wanted a test case to do. So we wrote an energy sum detector. It's very simple to do that, and so that was a good first case. GPL is much more complex. It has a file of parameters of its own, and it made a good second case of something to try to implement in MATLAB. The GPL detector that we're using is intended for humpback whale sounds. So for the first thing we do, let's load humpback whale sound file. So if you go to the detection workshop sound file examples, inside energy sum, that one, there are these humpback things. Use the humpback file that says one song in the name. For some reason, these humpback files have acquired a second .wave in their extension. I have no idea where that is. It's a file stream. When you're using this GPL detector, you have to have you need to have Matlab. So I'm going to quit this Matlab and launch a new one. So I have a fresh copy of Matlab. Matlab is on the desktop.
You want to do your spectrogram settings?
Yeah, I'll do that in a second. Okay, here's Matlab. Now back in Ishmael, I'm going to tweak this spectrogram. This doesn't actually matter too much because the GPL detector uses fairly much the raw spectrogram settings, so the brightness and contrast don't matter very much for it. For this detector, it's important not to have equalization. So if you have equalization turned on from something else, make sure that these boxes are turned off. Actually, the most important one is the floor, spectrogram floor value. That cannot be on, or it makes the Matlab code crash. It puts too many zeros in the spectrogram. That causes problems later on. Okay, let's see. The next step, when you launch Matlab, it should put you into this directory. Let's see, here. If you relaunch Matlab, it should put you in a directory named GPL, Generalized Power Law. So it's C, Ishmael, Ishmael 2.6, stub, plugins, GPL. These detectors are called plugins in the world. Stub is the system that Chris Marsh came up with for building these detectors that can be plugged into various pieces of software. This one plugs into Ishmael. And we want to run the GPL detector, so we're using the GPL plugin here. So you want to be in that directory. Hopefully your Matlab launched into that if you relaunch Matlab. Questions?
In the instruction booklet, it says to set the spectrogram to an FFT of 4096. Is that necessary
yes.
for the GPL, or is that just for viewing?
In this case, it's necessary for GPL. It was running so that the spectrogram size didn't matter. GPL could handle any spectrogram size you sent it. For some reason, these machines are crashing with the spectrogram size set to 2048, which is kind of default after you do the factory settings. So thank you for pointing that out. So change your frame size, your spectrogram frame size to 4096, like that. Okay. Forgetting anything else? When you're in the Matlab command window where you type in commands to it, type the command startup. First window you type. And then we're going to use the GPL detector. So the way we do that is on the detection menu. It says use stub plugin. It's this plugin system. You enable it. And then down here in function to run, there are two choices. One's an energy sum. That one doesn't work here because it's not set up right for this environment. But we want the GPL one. And we're going to specify low and high frequency bounds. Actually, these are pretty good. 100 hertz to 1,000 hertz is kind of the range we're talking about.
That again, I'm not getting that much.
How did it drop down?
We're gonna use that plugin.
Right. You got it.
It comes off detector.
Detector. Yes.
Yes, like, yeah, no copy.
Oh, this is okay.
Ese es el...
Okay.
Bueno, ¿se pone? ¿Qué lo han puesto directo? Pues...
done that, you have to start the Ishmael side and start the Matlab side. I'm going to start the Matlab side first. You can do them in either order once you get to this point. The way you start the Matlab side is you type the command GPL detector, all one word. If you use different capitalization, Matlab will say, tut, you used the wrong capitalization. Set up higher. Do you want to use the correct capitalization? And you say yes. So you run GPL detector. You don't see anything at this point, but it's waiting for Ishmael now. And so if I just click start in Ishmael. Now, don't touch your detection function. This is where this code is buggy. We want to see that detection function, but if you stretch it vertically, it causes a problem. Instead, go to the view menu and choose amplitude range. We're going to view amplitude range 1.5
Did you run startup first?
plus or minus 1.5.
First one startup.
That. And then run it again. Started Ishmael, started Matlab. Yeah. Is anybody getting a problem having the GPL detector run? Okay.
Just running some.
In Matlab, click on the Home tab and then Set tab. Right here.
Good thing it didn't crash.
You want to have this first thing. You click on Set tab up here. Look at this box. You want to have this GPL _V2_5 be in your short tab. Is that there for everybody? Or does anybody not have that? Just the relative path. Just where it's right there. It's okay if it's full path also. It'll work.
There you go.
So once you have that, click close. Again, in a normal Matlab, you can click save, and so it will remember that, and then forward. This will only remember that that's in my path until I exit Matlab and come back to it. And then I'm going to run my GPL detector again. Go back to Ishmael. I'm going to stretch things out a bit. That 4 times. Spread this out too.
Working on the bottom. Not supposed to. Should maybe use enable. Oh. Okay. Probably don't have to start.
Okay, if you watch the GPL detector running, you'll notice that it's Ishmael will
I think they start up with 4 a.m.
Ishmael will display a bunch of data, and then there's no detection function, and then suddenly the detection function appears. Watch how it Ishmael will kind of leap ahead or scroll ahead of the detection function, and the detection function runs to catch up. The GPL detector processes data in 75 or actually 70-second long chunks. So if your file is shorter than 70 or 75 seconds, it won't show anything down here at all. It won't have a detection function. As soon as Matlab, as soon as Ishmael gets through the first 75 seconds of sound, it'll show you 75 seconds worth of detection function. This detector is set up. It's looking at humpback units down here at the very bottom. 100 hertz to 1500 hertz, so that's about that much of the spectrogram. And it's getting detection peaks where there are humpback units here. Because of that 75-second chunk thing, it makes it difficult to stretch the spectrogram too much horizontally. The spectrogram can get way ahead of what you see in the detection function sometimes. I'm going to stretch it a little more just so I can see a little better what the world's going on here. My GPL detector.
So they'll never line up then?
Yeah, I mean, they'll line up some.
Okay.
They stop it in the screen right now. Run both. So here I haven't quite gotten to the first 75 seconds worth of data, so I don't have any detection function. As soon as it wraps around, it's going to get to 75. So they show me the detection function for the first 75. I've gotten to. This is one of those cases where Ishmael is far ahead of the GPL detector. So Ishmael's on 140 seconds, this is only on 65. So what I'm seeing here, the detection function does not correspond to the spectrogram. I'm going to try and fix that a little bit just by squeezing this so I can get a little bit more data on the screen. We run that. There we go. Okay, so here's the output of my GPL detector, and it's supposed to be detecting humpback units in the spectrogram. Sometimes it's detecting these fainter things, like that. Then it's detecting a faint thing right there, but most of these units correspond pretty well to things I can see in the spectrogram. That is a long one. It's hard to make for detection in that case. Let's see. Here, the spectrogram is wrapped all the way around to 200 seconds. This one is has wrapped around only as far as here, 130 some seconds. So this part corresponds to that part in time. But once I get past this is still on 40, 50, 60. So this does not necessarily correspond to that yet. So it detected that unit, but it missed a couple of them here. Detected that one, detected the faint thing in there, detected that one, detected that one. Let's see how this detector is working. Another screen roll. Nope. One's still behind the other. Oh no. So you can see the units. Most of these units should be lining up. That's that, there, that, that, that. You can see how the detector is operating. The GPL detector is a lot like the sound detector in that it it's either on or off. It's either making a detection or not. So setting a threshold is pretty easy for this one, like it mostly is for the tunnel sound detector.
What'd you do?
You can set a threshold here and pick off all the back units. You maybe want to smooth this a little bit. To stop things like, something falling down here from falling below threshold and splitting this unit into two. If you use the smoothing function, this would all smooth up the top of that pretty well. Let me do that.
Tell us a little more about what a GPL detector is and what features
Tyler could do that better than I can.
Yeah, go ahead, go. Try it.
Yeah.
I was just here watching you. To figure out what's going on. All you have to do is just do that. If you want to,
Yeah, sure.
but it doesn't really matter.
I put smoothing on when detection function is a lot smoother.
It might just be, I mean, sometimes it's just practice.
So, one thing I'd like to caveat this with, since this is not vetted at all yet between the two of us, is that inside the Matlab code there's a lot of smoothing and normalizing going on, and there's also a lot of smoothing and normalizing going on in Ishmael, and the two could be combating and not, might not be ideal. I think it's more of a proof of concept rather than don't pay attention to this yet, because I don't think it's right. Just looking at it I can kind of tell, but so GPL is a power law was developed by this guy named Nuttall in the Navy, and he published a bunch of sonar signal processing papers in the 80s, I think, 80s and 90s, and then it kind of went dark, and I don't know if it started to get classified or he retired or whatever, but so we took those series of papers, which basically give the optimal settings for finding signals of unknown, basically unknown character, so unknown length, spectral information, so kind of just a general transient signal. How do you optimally detect that? And the energy detector, which is in Ishmael, is actually a subset of power law. So when you take an energy detector, you take the Fourier components, you square them, and then you sum them up. The spectrum. The fact that you use the value of 2 is there's no rhyme or reason behind it. Besides, energy is something that in human terms we understand, right? So
two is squaring.
yeah, when you take the Fourier components. So not all saying, and it is, so the energy detector is the optimal detector if you're searching over the exact frequency bins that you think the signal is in. So the reason that it's, I think, personally overused for marine mammals is because originally it was detected for sonar signals, submarine signals, which are consistent over time. So it works really well for example, for air guns. Those span all the frequency bands you usually look over. They're very vertical, and energy summation over those bands makes sense for doing that. But for the case of humpback signal, here you're exciting just a few bands, but the signal is so variable that you're summing over a large stack. So when you do that summation, if you use energy, you're actually boosting the noise, which is in every bin, more than you're boosting these little transient signals, which is the opposite of what you want to do. So the idea behind power law is just to raise these spectral bins to higher exponents so that transient signals get a bigger boost in the summation. So if you were searching over all frequency bands and you're in, say, to infinity or whatever, and you had like just one frequency bin excited, you'd want to raise it to the infinite power to get the most signal noise ratio for that particular frequency. So so Nuttall said that if the signal is completely unknown, meaning you're looking over some range and it could occupy equally between one band and all those bands, you would use an exponent of 2.5. And as you get more and more transient, as in this scenario, you'd go higher and higher. So an exponent of around 3 or 3.5 is more applicable, and you'll see in the test statistic that you start suppressing the background noise a lot more in that summation. You get a much more consistent result. So the energy detector is just one class of this more general algorithm, which is essentially just that summation. Does that make sense?
So is it band limited at all? Is there any, do you specify the band or just the frequency, upper frequency?
So yeah, so you kind of say, okay, over what range could the signal, what frequencies could the signal occur in? So for humpbacks, you'd say, most of their calls would at least have some signal present between 100 and 1,000 or whatever. So that would be, you'd be summing over 100 to 1,000, which you would be raising those components to a different power.
For the GPL detector, one of the things in the parameter box I did detect use stuff plugin. We were looking at the algorithm, which is GPL in this case. The GPL algorithm from the Ishmael side allows you to specify what frequency range you want to operate in. And here I picked 100 to 1500 hertz because that's where the fundamental of those humpback units was. But I could choose anything I wanted there. If I were working on dolphins, I would enter much higher frequencies for that.
Yeah. So this is kind of like mostly used as like the last resort in a lot of situations, a lot of resort case when you have a signal like that doesn't have a characteristic. We want to try using your match filter, and it's one of the ones that we discussed. But a lot of times, if those things change over time, you can get in trouble because the signal, 6 months later looks a little bit differently, and all of a sudden your detector performance crashes. So even though these are, so when you use something like an energy summation or a power law detector, they are more robust generally to changes in the signal because they're looking at less specific attributes of the call. So that can be an advantage if you're looking at signals that might, or noise that might change over time. Yeah.
Am I correct in understanding that if you had a recording of, say, 10 different types of calls and you're really looking for just one call, this would be more likely to pick up all 10 calls? Like it doesn't like classify?
Yeah, there's no,
tabs.
exactly, yeah.
It's a template type detectors would probably be better. We want to overlay if they're in the same frequency range.
Mm-hmm. One thing that with our Matlab code that we use is we use the kind of the theory behind the power law to get to suppress the noise and get kind of cleaned up. I'm not going to call them spectrograms because they're not raised to squared powers. So to get grams, and we save snippets of those, and a lot of times those are much more robust to test against. So if you use those as a kernel, a lot of times you'll get much better results than because the noise is suppressed when you're doing like cross correlation, for example, things like that. So it is a nice tool for some of those things. But yeah, it's not a classifier. We started to kind of build classifiers after the fact, but it's not the intent of it.
Relative with energy some detectors. This stub interface has two parameters to it. I want to spend 2 minutes or maybe 5 minutes talking to people who might be writing their own detectors. I just want to show you what's available to you. Let's see. So let me show you what's from the Matlab side of things, what is in this detector. So one of the things in this slide is just the name of your detector, which I did up here. This is code that, if I were going to write a new detector, I would just kind of copy these files and name them, whatever the name of my new detector is, and then change this name. It's got an external name that you see on from within Ishmael, and an internal name, a description of it, which shows up in the Ishmael box also. I have this GPL detector, blah, blah, blah. Language is Matlab. Debug mode is true. That's the way it has to be right now. It's never going to work well, but soon you'll be able to type false, and then we won't have to do all the rigmarole of starting Matlab and doing the path business and typing GPL detector and all that. Once debug mode can be set to off. that'll all be automatic. It takes an input stream from Matlab, consisting of magnitude squared samples. So that's what the spectrogram is, as Tyler mentioned. The output stream is a detection function. Those are, for me, those are going to stay the same for all of my detectors. For a time series, a signal waveform detector, I'd be changing that magnitude squared. If I want to write a match filter kind of detector or something else that uses the signal. And then I get to specify what parameters show up in the dialog box in Ishmael. So we had one called low frequency and one called high frequency. You can recall in Ishmael in the stub interface, there's low frequency and there's high frequency. Those names just come from this file, this text file that I can edit. It's a Java kind of file. There's floating point numbers, the text box that you can type into. The default value is 100 for the low frequency and 1,000 for the high frequency. So that kind of tells Ishmael how to set up its interface. And then to write the detector, I have this thing called GPL detector. I started with the energy sum detector, which is the simplest one. It's got a lot of things about hooking up the stream that I didn't really pay attention to. There's one unit here called process data, where all the action happens. And this is the code here that I wrote that calls Tyler's GPL detector. The main call that does all the processing is called the GPL version 2 Dave. That's my modifications to Tyler's GPL detector. And so that calls and runs Tyler's process and gives me back a structure that has detections in it. And I convert those into something for the detection function and pass it out to the rest of this code down here does. So it was really, the amount of code I had to write for this was mostly about like that, to build an interface for Tyler's GPL detector. It's taken a lot of debugging to make it work, because this is the first time we were doing something this complex. But it was writing the code is not that complicated. And if anybody wants to do this, please let me know. I'd be happy to help work through it, as Tyler probably would too, to figure out how to write your own detector. The energy sum detector, you did that one too, just for comparison. Where did I have that one? Hold on.
It's going to be under C under your username.
Is it?
Yeah, I'll be dragging in your username.
Okay.
And then you set plugins.
Okay, here's the energy sum one. So here's the energy sum detector. It's even simpler. The energy sum code is pretty much that right there. Because all it's doing is summing some data vertically in the spectrogram. Actually, it's taking the mean of the data vertically in the spectrogram, and that's all that's needed. So it's a super easy one. And the energy sum one is a good one to look at to understand how things work. All right, I'm done talking about coders.
In theory, you could also use Java if you prefer that.
Yes, the plugin system is meant to make plugins that are in Java, so you can plug them in. Any other languages, Chris? Python? Or Python? Python person. Break the plugins in Python. Okay. Any more questions about this GPL detector? It's more kind of a proof of concept. I want to put it out there and have you have it in mind that if you think of different ways or something you want to try with the detector, it's now possible in Ishmael to roll your own, to do your own detector and have Ishmael run it. Ishmael, sort of interacts with the outside world with sound files or real-time sound coming in, and feeds it to your detection process, and then takes the results and plots them, and lets you make log files or sound clips or whatever. So Ishmael kind of does all the audio handling and lets you focus on the detection process. All right. I wanted to show one other demo, which is just what voice looks like. I'm going to do it on my laptop because this computer does not have a microphone. And I'm going to say, give me sound coming from a sound card. So this is every laptop has a standard PC sound card, and most PCs have them too. On a PC or a laptop, you'll see a sound jack for plugging in a microphone. Most laptops have a microphone also built in, so you can Skype or whatever, and just talk at your laptop and it will hear it. In Ishmael, you can say, I want to get sound from the sound card. It tells you which sound input you can use. Mine computer only has one, so there's only one option here, but if you have multiple sound cards or multiple microphone inputs or something, that's where you would pick it. You specify the sampling rate you want, and this will be a list of what's available from your sound card. And I want one channel here. I usually leave this box checked. And now it's listening to me. I'm not seeing much because brighter. Oh, it had a equalization process turned on. Okay. Okay, here's my voice. So if I talk at it, you can see what the voice print looks like. This makes a great demo if you're ever doing anything public outreach to do with your sounds. Interactive tested actually does it fairly regularly, I think. When people can see their own voice, or if you clap, suddenly you see bright bars appearing on the spectrogram. People, are like, oh wow, that's what it looks like. You can tweak the spectrogram parameters. Right now, if you look at this, these are the individual pulses in my voice. Those kind of pulses. You can adjust it so that you don't see individual pulses, but instead you see the longer duration pieces. Let's see, here we go. And you can see modifications of the spectrogram. Different verbs will look different, like if I say ah versus ooh versus e. You can see different parts of the spectrum get lit up. That's what different vowels are. They're just different regions of the spectrum.
Meow for them.
Right?
Meow into it.
Now you come in.
That's what I was gonna do. Let me
Only
know.
so far Dave will go.
I'll have a sperm whale.
But at public demonstrations when you're trying to, that's a good But people, we have open house at our lab and we do this. People can't tear themselves away, especially little kids. They like to make a burp into it. They're gargling, going and getting water and gargling into it, and barking and meowing. But they totally get what a spectrogram is just by doing this.
Yeah. Whistling is good. Anyway, it's a fun thing to do if you have a laptop or a computer with a microphone on it or something, a webcam or whatever. It's fun to do. Great to do. And then you can, if you're doing a public outreach thing, you can do this and then print your screen so people can take their own voice print homes. Remember it.
Where we show them like a blue whale call, and then they try to imitate, you know, we show them the species that you're studying and see if their voice print can match the studying. So we have a lot of teachers who are using it now for experiments in the classroom.
All right. Any questions? Any questions about this or the Matlab interface stuff? Like I said, that's code that is like, you know, kind of working this week or last week, some parts of it. So it's really new and still kind of buggy, but you know, within a month, I think we'll have a good version that's bulletproof. It's more bulletproof. Anyway. Okay. Let's see if I have anything else to say. Oh, I'm about done for today. We were behind schedule and now we're ahead of schedule. And I'm going to talk about localization, but I'm not quite ready to do that yet. I didn't have that prepared ahead of time. And I had quite enough time to put it together yet. But I will, I'll have that first thing in the morning to talk about how you do localization in Ishmael. And, I wanted to show you one other trick in Ishmael, which is if you set up Ishmael, you can zoom into a call. If you select something, if you click on this box here, well, it's GPL.
We're looking at your laptop.
Oh. Why don't you tell?
50-50, Sharon.
Turn off GPL detector. So if you quit the GPL detector, you have to restart the channel. Hear the sounds up there right now. Okay.
Put it in the Matlab.
There's my Beluga. Beluga again. You can select something and zoom into it. See, let me turn the detector off right now. You can zoom into it using this button here, and it'll take that call and zoom into the whole screen. Unfortunately, there's not an easy way to get back to your previous view settings. And this is another thing that we need to put in Ishmael. There is a way where you can get back to viewing the entire sound file easily, and that is just reopen the sound file. So I'm going to stop this. I say open file. Here's my Beluga, so I can just hit cancel. I don't even have to hit open. And then in the advanced tab, the start time and file has changed because I zoomed into something. I want to put a 0 in there and go back, and it should be because when I open that file, it says zoom to the window in time and in frequency. It should fit in the window again. Yeah, there's my entire file again. So that zoom to a call is a little bit useful. It's not great, and it's something that we're going to improve so that you can zoom to a call and then get back to where you were and you see things, see the previous view that you had before. Right. So right now, well, I'll mention this thing. In the appendix of the manual, there's something about grouping detections together. If you have Ishmael running through, and anytime you have like a cluster of calls that occur together, say you're detecting a sequence of calls or something, if you want to group them together into a single detection, you can do that. I don't have a good example of this, but it's one of the detection options. If you say, under saving calls, if you specify some numbers here, let's say 10 seconds and 10 seconds before the start of one detection, before the start of a detection and after the end of a detection, you say you wanted to save 10 seconds of extra data with your saved calls. Ishmael can then group detections together so that two detections that occurred where there are 10-second windows before and after the detection, after the first detection and before the second one would overlap. Ishmael will say, okay, that's no longer two separate detections, it's a single detection, and lump them together. And it'll lump together as many successive detections as there are, provided they would overlap according to this criterion, according to the saving calls criterion. This is true even if you're not actually saving the call, even if you're just making log file entries for your detections, it'll lump them together. This is kind of useful for, I found it useful for odontocetes. You know, when I've been studying sperm whales and every click I receive has a surface bounce or something like that that arrives at my hydrophone, you know, 10 milliseconds after the first click, the main click. It's really helpful to group those together because it's really a single click. I just happen to receive it twice. So I can use this mechanism to group detections together to get only one log file entry per click that I receive.
Yeah, we also use it for air guns when we're working on data sets that have seismic survey air gun shots that go on for days at a time. Instead of checking every detection, we can group them and check them in big giant clumps that saves a lot of time.
Yeah, it's a way of, if you have a sequence of things that you want to consider as a unit, this is a good way to do it.
Right.
All right. Ishmael tricks. So it's before and after this the call and the saving calls tab, and then in the advanced window, you save successive calls together. All successive detections together. Okay, that's all I have for today. Tomorrow, the idea is that we're gonna, people who have brought their own data, we can work on doing detections in that data and maybe characterizing the performance of your detector if you like. We will also have a test data set or two to provide. If you didn't bring your own data, we'll put one on the file server so that you can work on something on your own. The idea is going to be that you do it, you know, that we only help you do that stuff, that you use the stuff you've learned this week yesterday and today, to design your own detector, run it on a big data set, get the resulting log files, and see what they look like, and maybe characterize the performance of your detector. So that's the agenda for tomorrow. Let's see, is Liz here?
Hey.
Yeah. Do you want to talk about dinner?
Oh, I don't.
Yeah,
What time are we supposed to meet
people
there?
can go over whenever they want. Happy hour's, I think, started already. So all the
We're late.
What do we make it?
Really, we're stopping at
all the lunches can go now.
Pick a time to-
But they will be serving. So happy hour ends at 7, and that's when we make dinner reservations. So those of you that want dinner, if there's more than 10, then we have to tell them. Let's probably, I don't know if it's too late, but I don't think it's going to work. It sounded like this morning it's not going to be more than 10. So I think we're
Okay,
good.
why don't we, well, I will end up get there around 6. If you want to go earlier, that's fine too. And start hanging out in the bar and happy hour. But I'll go at 6 and maybe you can see something there. And then we'll stay for dinner afterwards. All right.
If you want to catch the sunset, get there by. If you want to catch the rain, severe weather watch. It is severe California weather watch.
Rain,
All right. Oh, I did want to get a group photo before we break for today. I don't know if everybody's going to be here tomorrow, so while we're all still here, let's go outside. I think, is it raining right now? Or is it here raining? But can we do it outside? Okay. So we know
No, I'm being perfectly friendly.
You're gonna go straight there?